Lesson number 32, factors and multiples. So first, there's some vocabulary we have to know. So the first are factors. Factors are all the numbers you multiply to get to another number. So for example, if we start with the number 12 and we ask, what are the factors of 12? Well, first of all, any number will always have two factors. It will always have 1 and itself. So 1 times 12 is 12. So 1 and 12 are factors of 12. Well, what else? Well, 2 times 6. Those are also factors. 2 times 6 equals 12. And last we got 3 times 4. 3 times 4 also equals 12. So these are all factors of 12. 1, 2, 3, 4, 6, 12. Those are all factors of 12. When you multiply them by each other in pairs, then they equal to 12. Next, we have multiples. A multiple is the number you get after you multiply two factors. So let's say we start with the number 3. When we say, what are the multiples of 3? Well, 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12, yada, 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 yada. So those are all multiples. Those are all multiples of 3. Is when you take a number and you multiply it by another number, you get a multiple. So those are called multiples. Then we have what's called prime numbers. A prime number is a number that only has two factors, one in itself. So for example, 2 is a prime number. 1 times 2 is 2. There's no other factors. Let's see, 11 is a prime number. 1 times 11 is 11. There's no other factors. 19 is a prime number. 1 times 19 equals 19. 23 is a prime number. 1 and 23 are the only factors. So again, a prime number only has two factors. It's 1 and itself. And then we have what's called a composite number. And a composite number is a number that has more than two factors. So we talked about 12 before. 12 has many factors. 1, 2, 3, 4, 6, 12. That's a composite number. 15 is a composite number. 1 times 15 is 15, but also 3 times 5 is 15. So a composite number, unlike a prime number, has more than one factor. Now, here's a list of divisibility rules. The divisibility rules are if you're looking at larger numbers, can you figure out what the factors are very quickly without having to try to guess it? Now, I'm not going to go over all of them, but I'm going to go over 3 of them because if you know these 3, then you know a good amount of factors. So the first one says, all right, if a number is even, it means it's divisible by 2. Well, remember, even numbers are 0, 2, 4, 6, 8. So what it's saying is if the last digit of a number, the last digit of a bigger number is an even number, then you already know it's divisible by 2. So for example, if I look at 24, well, the last digit of 24 is even, 4, so you know it's divisible by 2. Another example is look at 78. The last digit of 78 is 8, which is even, meaning it's divisible by 2. I mean, it doesn't matter how big the number is. It could be 2056. Well, the last digit of 2056 is 6, meaning it is divisible by 2. So right off the bat, if you know the number is even, you know it's divisible by 2, and you know already that that's a factor. The next rule is the divisibility by 5 rule, all right? And this one's pretty straightforward also, meaning what it's saying is if the last digit is a 0 or 5, the whole thing is divisible by 5. So for example, if you have the number 30, well, the last digit in 30 is a 0, meaning it's divisible by 5. What about 75? Well, the last digit is a 5, meaning it's divisible by 5. Again, it doesn't matter how big the number is. It could be 1035. Well, the last digit is a 5, meaning it's divisible by 5. So again, if the last digit is a 0 or 5, you know that the whole number is divisible by 5. You know that 5 is one of the factors. And the last one I want you to focus on is if the last digit is 0, it's divisible by 10, always. So if you have the number 90, the 0 means it's divisible by 10. If you have the number 230, the last digit's 0, divisible by 10. Again, it doesn't matter how big the number is. You could have 4,070. Well, the last digit's 0, it's divisible by 10. All right. So if the last digit's 0, it's divisible by 10. Now, I know you're going to ask, well, wait a minute. If it's a 0, that means it's, well, even. All right. Well, it's also divisible by 5. Well, it's also divisible by 10. Yes, that's right. That means they're all factors of it. So, for example, if you have the number 40, one of the factors is 2 because it's even. One of the factors is 5 because it's a 0. And one of the factors is 10 because it's also 0. Remember, composite numbers have more than one factor. All right. So just because the rule works for one, it can still work for another number as well. All right. Let's look at examples. So here it's asking which number is a prime number. Now remember, a prime number can only have 1 and itself as a factor. So let's look at A. All right. Well, let's look at the factors of A. Well, again, 1 times 9. 1 in itself will always be a factor. But guess what? 3 times 3 also equals 9. So 9 has 3 factors. That is not a prime number. That's a composite number. Let's look at 18. Well, the factors of 18, again, you always start with 1 and itself, 1 and 18. Well, guess what? 2 times 9 is also 18. Well, and also 3 times 6 is also 18. So 18 has 6 different factors. That is not a prime number. Let's look at 26. Well, again, 1 and itself are always factors, 1 and 26. Well, guess what? 2 times 13 is also 26. So 26 has more than 2 factors, so it's not prime. Our answer is 37. The only factors for 37 are 1 and itself, 1 and 37. So if a number, again, only has 2 factors, if the only factors are 1 and itself, then it is a prime number. All right, let's look at this question. It says, which is a multiple of 6? Well, to figure out the multiples of a number, all right, start with this number and just start multiplying it until you get to which one's a multiple. So 6 times 1 is 6, all right? 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 36, blah, 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 blah. Well, looking at our answers, we got 16, 18, 26, and 28. Which one is a multiple of 6? Well, 18 is a multiple of 6. All right, so the question here is asking, which is a factor of both 42 and 14? All right, well, when you're looking at a problem like this, you could start writing out all the factors for both numbers. But here, what you want to do is just start with the smaller number. Okay, start with the smaller of the two numbers. All right, and figure out those factors. Because the larger factors of 42 aren't going to work because the smaller ones won't go that high. So once you figure out the factors for the smaller number, then you can figure out what are the factors for the bigger number, all right? So let's start with 14. What are the factors of 14? Well, again, 1 and 14, 1 in itself are factors, all right? And then we got 2 times 7, all right? So looking at these, what is a factor of both 42 and 14? Well, 1, obviously, right? 1 is always a factor of any number, all right? Well, 2 is also a factor of 42, right? 2 goes into 42, but that's not one of our options. Well, guess what? 7 is a factor of 42 also, because 7 times 6 is 42. So 7 is a factor of 14. 7 is also a factor of 42. And our last question says, which of these is a composite number? So again, remember, a composite number has more than 2 factors. So let's look at the factors for all these numbers. Well, let's start with 3. What are the factors of 3? Well, 1 times 3 is 3, and that's it. Okay, so that's a prime number. Let's look at 5. Well, 1 times 5 is 5, and there's no other factors, so that's not it. Okay, let's look at 6. Well, the factors for 6 are 1 times 6 is 6, but guess what? 2 times 3 is also 6. So 6 has 4 factors, meaning it's a composite number. Let's just do the last one just to make sure. 7, well, 1 times 7 is 7, and there's no other factors. So 3, 5, and 7 are all prime numbers. The only composite number is 6 because 6 has 4 different factors.